Hello, I am David W. Parker. This is Programming Today I Learned, 3D Math Series, Episode 13. We're going to be looking at more linear transformations today with matrices. And today we're going to be starting off with some scaling. So we know that we can make an object bigger or smaller by scaling by a factor of k. If all directions use the same scaling, it's called a uniform scale. If the absolute value of k is less than 1, the object will get smaller. If the absolute value of k is greater than 1, the object will get bigger. And next episode we'll look at if k of 0 will have an orthographic projection and k is less than 0, we will have a reflection. So we're going to scale on cardinal axes because we're not doing any translations, as you remember. So we have two scalars here, k of x and k of y. Basis vectors of p and q are each affected by the respective scalar. So p prime is equal to kx times p. So you can see here we have this very simple basis vector 1, 0, which is going to be k of x 0, and for q it's going to ultimately be 0 k of y. You can put these together to build our matrix here, and you have k of x 0, 0 k of y. To do this in 3D, obviously we just add k of z, and then we have this identity looking matrix with the kx, ky, and kz values respectively. We can also scale in an arbitrary direction. Note that n is going to be the unit vector parallel to the scalar vector k, and for the vector v. So we want to compute v prime in terms of this scalar k, this unit vector n, and the vector v. So you know we can break a vector up, as we saw in previous episode, into v parallel and v perpendicular. V parallel is just v dot n times n, and we saw that previous episode. V perpendicular is perpendicular, so it won't be affected by k. So we know that v prime is equal to v prime parallel plus v perpendicular. We just need to compute v prime or parallel, which is just k v of parallel. So moving right along, if we're going to compute this in terms of v prime, we're just going to go ahead and replace each of these values, which we already know, with their respective values for v prime perpendicular and v prime parallel. Obviously this is the only one affected by k, that's why the k is over here and not on this side. And then we can factor out the n v dot n and the k minus 1, so we end up with this ultimate equation right here for v parallel, for v prime, excuse me. So now that we know v prime, we can go solve for all our basis vectors. So let's do it for p right here, 1, 0. So p prime is going to be, this is the equation, the previous equation, just replacing p's with where the v's are. And we're going to use column vectors again, just like the last episode, to make things easy to see, but in general we're using row vectors here. So you could see that the p values are getting replaced, and the n values are being replaced with nx and y's. And then we'll have this ultimate p prime here once everything has been multiplied out. And it's pretty simple to see. You can do each step and show your work. Obviously, I skipped a few steps, but trust me, this is what it ultimately is. We can do the same thing for the q basis vector in 2D. And that'll allow us to create our ultimate arbitrary scalar matrix here with the p prime values across the top and the q prime values along the bottom. Similarly, we can do this in 3D to solve for the basis vectors. You would just go ahead and put this p value into the equation right here to determine what their values are going to be. And it's kind of a very, very standard approach where you'll see that's the nx squared times this formula, and then k minus 1 times nx and y, and nx and z. Same thing for the next one, it'll be nx and y and z on the bottom, and then the formula here with ny squared. Finally, this one will be the nz squared formula, and then nx and z, and ny and z. So you can put those together to build our ultimate scaling in a arbitrary direction matrix here with the the basis vectors for the x, y, and z, for p prime, q prime, and r prime across the top middle, and bottom row, respectively. So those are some nice equations that you can use to figure out how to scale anything in 3D in arbitrary directions. Granted, it is going somewhere along the origin because we have not done any translations. And that's it for this episode. If you like what you saw, go ahead and subscribe and give me a like. Share this on social media if you will. Go to ProgrammingTIL.com and sign up for my newsletter. Have a great one.